Okay, so let's get started. We're going to be taking a look at working with our traditional fuel equation mode within our Link G5 and G4X programming. Now, we had an introduction into the traditional versus model mode earlier in the training course. Now we're going to focus on what the traditional mode actually represents and it means, and we're going to be working with just understanding these basics in this particular training tutorial. The next training module, we're going to be taking a look at setting up the main fuel table and the master fuel trim value based on our Excel spreadsheet calculators. We're going to dig into that, learn how to do breakpoint rescaling, and just learn how all the settings here should be configured within this fuel main window for our traditional mode. But again, the focus here is just understanding the fundamentals and the basics for this training module. Now, the traditional mode simplifies our fuel tuning. We don't have any math modeling going on in the background. If we keep all of our corrections here set to off, very, very simplistic the way this is going to work. So we're going to be taking a look at that here in just one second. But we have a few different variables that we have to account for just in the basic calculations for the traditional mode. We want to find here that the load equation load source is set to load equals map. What this is going to assume when we set it to load equals map, which is how we're going to configure it for 99.9% of the engines we're tuning with the Link in the traditional mode, load equals map assumes that if you double your map pressure, you're doubling your injector pulse width. So very simple kind of modeling going on in the background. This is traditionally what we set this at. Load equals baro is assuming you have no map pressure sensor or an unreliable map pressure sensor reading, in the case with individual throttle bodies in an alpha N style tune. That's going to be what we choose for that particular occasion. So it's going to be changing our fueling in the background based on baro pressure changing. Load equals baro over map crossover. That's a unique situation where when we're below in vacuum, let's say below 0 psi atmospheric pressure, we're going to be running our baro pressure sensor for our reference and our calculations for the fueling. And then above positive manifold pressure, we get into boost, we'll be using the map sensor to do that double calculation. So if we double map, we double our injector pulse width. This is used for something like an RB26 engine that's fitted with individual throttle bodies and its force induction. So a bit of a unique situation. We traditionally don't use this. Load equals off is something that I never have to use with the Link, so we don't need to worry about that. But the load equals map is what we generally select, whether we're in the model mode or the fuel equation mode. This means you have a good map pressure sensor reading, everything's stable. We want to be able to have that double pulse width to manifold pressure relationship in the background. Okay. Then we have our master fuel and our master fuel trim value. Now the master fuel value is going to be a pulse width scalar. You can think of this as kind of a global pulse width. This indirectly is going to be a way we scale for the injector size that we're dealing with. So if you change your injector size, let's say from a 300 cc new injector to let's say a 1200 cc injector, you're going to be changing your master fuel trim value here, not master fuel trim, master fuel value here. You'll be changing this value, and then you can fine tune and adjust your main fuel table. So the master fuel value is going to be working in conjunction with your fuel table value. These values are a percentage of the master fuel value. Now the goal is to get our table values so that they're pretty reasonable in terms of the value in the table. There's no right or wrong percentage values to have in the table here, as long as when you're going in and you're programming a desired target lambda, you're hitting the target lambda on your measure target lambda setting here. So that's going to be allowing us to kind of get things sorted out. Now, we do want to find that we have reasonable resolution, meaning that if we're raising or lowering the numbers, we're not at the upper or lower end of the scale in terms of our adjustment value in the table. So we don't want to go and have our values at idle here, let's say at something like 10 or 20. That doesn't give us a lot of adjustment. Likewise, we don't want to see the values at something like 100, 140 at idle. That means that something is definitely not right, and it's likely going to be caused from our master fuel value here being incorrect. Now the master fuel trim value is going to be a percentage multiplier across idle, part throttle, and wide open throttle. You can think of this as an overall fuel scalar. So if we're finding that at idle, part throttle, wide open throttle, for whatever reason we're running rich or lean, you can simply go in here and add or subtract a certain percent. This will scale your injector pulse width up or down a certain percent and ultimately scale the injector flow and the fuel flow into the engine by that amount. So master fuel trim value, we generally leave at 0, and we're going to be scaling things between our master fuel value and our main fuel table right here. This will make a little bit more sense here in just a minute. Now we do have a couple other things that we can program and to work with in our traditional mode. We have an open loop lambda correction. Now if we set this to off, what this is going to do is say that when we're in closed loop correction, we'll be looking at the desired target lambda table here. But in open loop, it'll ignore the target lambda values. We want to typically set this so that it's on. So if we're setting this up, we want to set this on. So this will act like when we're in the modeled mode and we set our target lambda table, we dial in our main field table, and we want to go back in and change our desired target lambda, we can simply just change it in the table without having to retune our main field table. That was one huge advantage of the modeled mode. We can simulate that same thing by clicking this on. Lambda target table.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.